Example 5 from the Solving Rational Equations lab. We have f of x is equal to 30 over 3x minus 40 over 3x plus 3. We want to find the values of x where f of x is equal to 1. So the first thing we're going to do is substitute f of x equals 1 for this right here, this f of x. So we have 1 is equal to 30 over 3x minus 40 over 3x plus 3. And we want to solve this equation for x, what values of x it can be. So what we're going to note first is what our x cannot be. So we know that when we have a number divided by 0, that it'll be undefined. So 3x cannot be 0, and 3x plus 3 cannot be 0. So if 3x cannot be 0, then x cannot be 0 for this fraction right here. And if 3x plus 3 cannot be 0, then x cannot be, so if we have 3x plus 3 cannot be 0, minus 3 on both sides, we have 3x cannot be negative 3, divided by 3, we have x cannot be negative 1. So we have two values here of x cannot be 0 and x cannot be negative 1. So moving on to solving for this equation up here, we're going to find the LCD, the least common denominator. So we have the denominators of 3x and 3x plus 3. And so we have the denominators 3x, and we have the denominator of 3x plus 3. Now 3x plus 3, you can pull out a 3. So it's 3 times x plus 1. So if we look at all the factors, we have a common factor of 3 between 3x and 3x plus 3. So we only need to have the 3 once. We have a factor of x. That's not in common with this one. So we have to add the x. And we have a original factor here of x plus 1. So we have to have the x plus 1. So our LCD is 3x times x plus 1. So we are going to take this LCD and multiply it by each side of this equation right here. So we're going to have the LCD, 3x times x plus 1, times our left side of our equation, which was 1. And then we have the right side of our equation, which was 30 over 3x minus 40 over 3x plus 3 times our LCD, 3x times x plus 1, like that. And distributing through, this 1 will just make this on this left side of the equation. So distributing this through, it's just 3x times x plus 1 on the left side of the equation. On the right side of the equation, we have to distribute this twice to these two terms like that. So if we have 3x times x plus 1 times 30 over 3x, this 3x here will be on the top and the bottom, so it will cancel for this term here. So we're only multiplying this 30 times x plus 1. So we're left with 30 times x plus 1 for the left term. Now we have the right term right here. So we have this right term of 3x plus 3. Now remember that 3x plus 3 factors to 3 times x plus 1. And we had the factor of 3 times x plus 1 up here. And so this 3 and this x plus 1 will cancel with the denominator here, but this x right here will not cancel. So we're left with 40 times x, and that's just 40x, like that. So continuing to simplify and distribute, we have 3x squared plus 3x on the left side. On the right side, we have 30x plus 30 minus 40x on the right side. And I'm going to move everything over and simplify to the left side. So we have 3x squared, and we have plus 3x minus 30x minus 40x plus 40x, since we're moving it over. And minus 30 is equal to 0. So we have 3x squared. We have positive 3x minus 30x plus 40x. Well, 40x minus 30x is 10x plus 3x is 13x. And we just have this negative 30 here is equal to 0. So what we need to do now is factor this polynomial now that we have it in simplified form. So we have our a is 3. So we know it's going to be in the pattern of 3x plus or minus something times x plus or minus something is equal to 0. And we have our negative 30. We need to look at the factors of negative 30 that, depending on which position they are in, they are going to add to 13. So we have the factors of 6 and negative 5. And if we have our 6 here and our negative 5 here, it'll add to 13. Because we have 3 times this 6, which would be 18, and then minus 5 would be 13. So we have this equal to 0 in two cases. So from this we have 3x minus 5 and x plus 6, and they're both equal to 0. So x can be, from this one, if we add 5 to both sides and then divide by 3, be 5 over 3. And x on this side would be negative 6. And if we remember our domain restrictions, x cannot be 0 or negative 1. Here x is 5 over 3 and x is negative 6, so those are both valid solutions.